Welcome back. We are going to do some problems for the review for exam 1. So this is the kind of review for exam 1. Review for exam 1. Please go over all the following videos to follow regarding the exam 1 and of course the previous videos which we talked about the homework. So let's take a look at problem 1 in our review. So the problem 1 in our review, basically given a differential equation, I like to solve for y of t by using Laplace transformation. So here's the differential equation. The differential equation here, is d squared y dt squared plus 7 let me see, dy by dt, then I would like to put this as 12y, and let's say this is a unit step function here, and let me call this 12u of t. Alright, so given the differential equation, this is your differential equation, and this is given, right? So given the differential equation, so given is what we call is the differential equation. Yeah, so don't get scared. We are going to solve this differential equation using the Laplace transform. So we are looking for the solution of y of t. Okay, so this is given. And also we are going to assume that the initial condition equal to 0 also. Initial condition is 0. Okay, so here we go. So now we can easily do this. So step number 1 is to of course write this as a Laplace transform of this d squared dy dt squared plus 7. This is a symbol for Laplace transformation, like this, right? So dy by dt plus the 12 Laplace transform of y is equal to 12 Laplace transform of u of t. There we go. So now, as we recall last time and refer to that golden Laplace transformation table that we have talked about not several times but a couple of times since last week. So here we go, we can look at that table and we can say, hey, the Laplace transformation of this in the frequency domain or the s domain will be equal to s squared y of s plus 7y 7s y of s plus 12y of s. Here you go, 12y of s, right? That's the left hand side of the equation. On the right hand side we take the Laplace of the unit step function, and that will be equal to 12 over s. Okay, now we can factor out y of s, so let's do that. So inside you are going to have s squared plus 7s plus 12, and this is equal to 12 over s. Sounds like little complications over here, but we are going to do the FOIL method to solve this equation right here. So this is not a big deal. Picked up some good numbers for you. 4 times 3 is 12, so that will be equal to s squared plus 4s plus 3s plus 12, and on the right hand side you have 12 over s. Well, from here it's not that difficult. Now we're just doing algebra, right? So you see how easy it is to solve for y of t. We're not there as yet, but once you take the Laplace transformation from the table, then it becomes just simply solving a pure algebra problem. So s is common here, so s plus 4, and you can factor out 3 from here, so this is going to be s plus 4, and this guy is equal to 12 over s, right? There we go. So now let's go ahead and do this a little bit more work here. So my friends, this will be equal to y of s And of course you can see that s plus 4 times the s plus 3. We're almost done as far as the formulation is concerned, right? So this is 12 over s. Well, we can find y of s from here now. So y of s here is simply equal to 12 over s times s plus 4 times s plus 3. Looks a little complicated to take the inverse Laplace transformation of this y of s. Well, not really. What we are going to do is we are going to apply partial fractions. If you don't know how to do that, let's go ahead and do it now. So this is on the left hand side, we have 12s times s plus 4 times s plus 3. Some people write it k. Well, let me just write a. So a over s and b over s plus 4 plus this 4 should not look like a 9, right? Plus c over s plus 3. Here you go. Now, all you gotta do is take this guy on that side, and 12, that will be s cancels out, that will be s plus 4 times the s plus 3. Here we go. And you can write this as bs times s plus 3 plus cs times s plus, well, s plus 4. Here you go. Now, while some people will open up this and try to compare the coefficient to the left and the right hand side of the equation, but you could also do it in an easy way too. If you want to get rid of c, all you got to do in first round is put s is equal to 0. If you do that, b is gone, c is gone, right? So here we go. 12 is equal to a times the 4 times the 3, and then of course a is just equal to 1, right? So we are done with a. How about b? How do we get b now? Well, let's take a look at it. How do we do that? So in order to get b, we need to get rid of a and c, both of them, right? So if we do that in the second round, I put s is equal to minus 4, I get rid of c, and also get rid of a too. So now let's see what we got. We got 12 is equal to b times minus 4, and this guy here is minus 4 plus 3, so that is pretty interesting. That will be equal to b minus 4 times minus 1, so that means that 4b is equal to 12. Then b will be equal to 3. Alright, how about c? Well, let's think about it. How are you going to do c now? Well, you need to get rid of both a and b to get c, don't you? So, well, we put s is equal to minus 3 on this round. Round number 3. Okay, so this is gone and this is gone. And what do we got now? We got 12 is equal to c minus 3, and this guy is going to be minus 3 plus 4. So what do we have here? We got minus 3c is equal to 12. So c is equal to minus 4. Well, here we go. We got 1, 3, and minus 4. Okay. So all we got to do is plug it in here, right? So, well, the first one is 1. So let's put that in there. So this guy is 1 over s plus 3 over s plus 4, and then you have minus 4 over s plus 3, and all this is equal to y of s. Well, in this format, the advantage of taking the inverse Laplace transform here was to really get it in the format where you can go to the table and be able to solve this. Okay, so we take the inverse Laplace transform, remember Laplace, and put an inverse sign in there. Inverse Laplace, boom, like that. like that, and then like that. Okay, so you know that the inverse Laplace transform, let me write it in a better format here. So y of s and here we go, inverse Laplace transform of minus, inverse Laplace transform of 1 over s plus, take out that 3 out, so inverse Laplace transform of s plus 4 minus 4 inverse Laplace of 1 over s plus 3. Well, we got our table again, don't we? So we can go to that table and be able to find what we are looking for. We are looking for y of t, right? So y of t, inverse Laplace of 1 over s, as you recall, is u of t. All this is coming from the table now. Plus 3 e to the power of negative 4t u of t, and then plus minus 4 e to the power of negative 3t, let's make it look like 3 also, 3t u of t. Okay, so we can factor out u of t if you wanted to. So this will become 1 plus 3 e to the power of negative 4t minus 4 e to the power of negative 3t u of t. So this is the solution using what we call solving the differential equation using Laplace transformation. And this is the review problem number 1 for your exam. I will see you shortly in the next video. Thank you.